You're welcome to day 49 of 50 days of tutelage. In today's class, I'll be discussing about probability. Of course, in the last class, we discussed about statistics already. So what is probability? Probability, you can simply see this as an English word, is more like likelihood, like the opportunity of an event happening. When you say probability, so how close to happening is this event? Or how close to not happening is this event? That's basically what probability is about. So uncertainty. Sometimes you have high level of uncertainty in some events happening, and sometimes you have low level of uncertainty in some events happening. So when we represent this thing mathematically based on some empirical events, then we have the concept of probability. And so that makes me start this way. The first thing we notice is that mathematically we want to represent probability in fraction form. So probability is going to be in fraction form. And one thing we know about fraction is that fraction has a whole. So if you say a whole fraction is always of the unit value, which is what? Which is 1. So if something is whole, you say 1. When you begin to take part of a whole, like 2 over 7, like 3 over 5, like 1 over 4. So what you're saying is that this is 2 out of 7, this is 3 out of 5, this is 1 out of 4. But when you take a whole of everything, for instance, you can say 5 out of 5. So you see that the whole of this fraction is 1. But not having anything at all out of this is having 0, like nothing out of 7. So that would be 0. So which implies that we can actually create a boundary for what probability is. So probability is going to always be, because likelihood of event, you are picking event from event. So now you can choose not to pick anything at all, or you can choose to pick everything. So your probability is always going to range from that region. So we have 0 is less than or equal to probability value, and this is less than or equal to 1. So that implies that the least value you can have for probability is 0, and the highest value you can have for probability is 1. The moment you have 1 point anything, then you probably have done something wrong. And when you have negative results, you have done something wrong as well. So that's the basic introduction to probability. So let's go over the definition again. It is the measure of the likelihood that a given event will occur. So we express it in numbers between what? Between 0 and 1. So when you have 0, 0 means that that event is not going to happen. So it is impossible for the event to, that is in fact, 0 is a level of certainty itself. Certainty of the event not happening. And 1 is also a level of certainty of the event happening. And that's basically what we have there. So there's a general formula that we use to find probability. So probability of an event happening is given as number of favorable outcome of the event of over number of the sample space, the total number of possible outcomes. So we have what we call total number of favorable outcome. So this has to deal with favorable outcome, and this has to be deal with possible outcome in that event. So favorable is what we are interested in. Possible is everything that is there. So this S represents what we call a sample space. It represents what we call a sample space. So let me quickly define each of these things. What is a sample space? A sample space is the set of all possible outcomes of an experiment. Set of all possible outcomes of an experiment. So if I give you a situation now, anything that can happen in that situation, when you gather all of them together, the set of such is called the sample space. Now, when you now put n now, n means the number of all of these possible things. So for instance, if we're taking an event and then we are considering, let's say we have a blue ball, we have a red ball, and we have a green ball. So the sample space contains these guys, blue ball, red balls, green balls. And the number of those, and the cardinality of that set is 3. So when we say favorable outcome now, let's say I want to pick one of these guys now. So if I want to pick one of these guys, I just want to pick a ball at random. That implies that I can actually pick a blue ball, or I could pick a red ball, or I could pick a green ball. Those are favorable outcomes. That is picking one out of the entire sample space. So that is how you find probability. Another thing again is to event. Event is a subset of the sample space, like I've already explained that already. Also, one thing we know about events is that if you have the probability of an event, let's say this is the probability of the event happening. Now, then you have the probability of the event not happening, the likelihood of the event not happening. Then when you add these two together, it's going to be equal to 1. So that implies that if you know the probability of positive outcome, then the probability of negative outcome will just be 1 minus the probability of positive outcome. So that's basically that. So let's look at different events that we have in probability. We have events that are mutually exclusive events. Mutually exclusive events. In this case, we're talking about two events that cannot occur at the same time. There are two events that cannot occur at the same time. That implies that if one happens, the other one cannot happen. If the other one is happening, the other one is not going to happen. So, an example of this is if you have a coin. So, a coin always has two sides. So, let's have these two coins. That does not look like a coin. Aha. So, if you have a coin now, a coin, you have head or you have tail. Now, when you toss this is the same coin anyway, so let me look them together so that I know it's the same coin. When you toss this coin into the air and it falls, it's either you have head or you have tail. You cannot have both of them at the same time. So, therefore, they are mutually what? They are mutually exclusive. So, when you say probability of having A or probability of having B, like when you say probability of having A or B in a single event, so it's going to be probability of A plus probability of B. So probability of having A or B in a single event is going to be probability of what? A plus probability of B. That is why in the case of this guy, head and tail, the probability of having head and tail, the total number, the sample space is head and tail. So the total number of sample space, the cardinality of the sample space is 2. Therefore, the probability of having head is just one favorable. Head has only one favorable outcome here. So the probability of having head is going to be 1 over 2. And the probability of having tail is going to be 1 over 2 as well. So what is the probability of when you toss a coin in the air that you have either head or a tail? You know definitely that is definitely sure that you will always have either of this guy. So therefore, if you add the probability together, 1 over 2 plus 1 over 2, that's going to be 1 because the two of them, one of them would definitely happen when you toss a coin in the air and something like that. So that is for mutually exclusive events. So we have independent events. So just from the way they sound, independent events, they are events that they do not affect each other. So the way one happened does not really affect the way the other one is happening. So example, if you have you toss a coin and you roll a die, it tossing a coin does not necessarily affect the rolling of a die. There are two different things and they don't affect each other. So we have a way of finding the probability. So probability of finding A and B, that is such events A and B that are independent rather. So their probability or is going to be probability of A multiplied by probability of B. So when you have such events that are what? Independent events. So probability of having A and B, that is when you do them, you have the two of them happening at the same time, then that will be probability of A multiplied by probability of B. So what we notice here is that when we are using OR to represent a particular statement, there is always introduction of addition. When we're using AND to represent a particular statement, we always use multiplication there. And we have dependent events as well. Dependent event is such that the outcome of one event affects the probability of the other. So when you have, for instance, now when you are doing probability without replacement, we'll talk about that when we look at some work example. So when we have probability without replacement, so this actually makes such that the happening of one affects the next event that is going to happen because you are doing something without replacement and all of that. So that's when we have dependent events as well. So let's move on. We have the addition and multiplication rule, which I've kind of hinted you a little bit already. So I've said it already. When you use, so sometimes when you are dealing with probability problem, you can interpret it as a statement. So when you interpret it as a statement, if you use the or English, then you are looking at addition. And if you use the word and, you are looking at multiplication. So take note of that. So for instance, if two events are not mutually exclusive. If they are not mutually, I explained mutually exclusive earlier. So for mutually exclusive events, which is what I explained here, A or B will be probability of A plus probability of B. But if they're not mutually exclusive, that means that it's possible that the two of them can occur at the same time. Like there can be a situation whereby A and B they are appearing at the same time. So the probability of A or B in that case is going to be probability of A plus probability of B minus the probability of A intersection B minus the probability of A intersection B. So this is because there is a place where the two events can actually intersect. So you have that in the whole situation as well. But if they are mutually exclusive, only this part will be needed in that situation. And that's for mutually exclusive event. So for multiplication, I've said if you have and you just use multiplication like that. So let's take a few examples. Let's take a few examples. For instance, if you have a bag that contains 5 red balls. So you have 5 red balls. Then you have 3 blue balls. So let me use blue for that. Do I have blue in this place? Okay. Blue, 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 blue. Yeah. So you have 3 blue balls. Three, three blue balls. So what do we have here? Find the probability of picking a red ball at random. So this one is very easy. So find the probability of picking a what? A red ball at random. So to pick a red ball at random, all you have to do is that the cardinality of the sample space is going to be 5 plus 3, and that's going to be 8. So if you want to pick a red ball at random, what's the number of favorable events, like favorable outcome of picking a red ball? That's 5. So the probability of picking a single red ball at random is going to be 5 divided by 8. And that will be the probability of picking one red ball. So let's look at uh, other events, like independent events now. If a coin is tossed and a die is rolled together, find the probability of getting a head and a 6. So you toss a coin, and then you roll a die. So a die always has 6 faces. So where you have 1, 2, 3, 4, 5, 6. So if I say you should find the probability of what? Obtaining probability of getting a head, obtaining a head, and also getting a 6. So probability of obtaining a head, that's 1 over 2, multiplied by probability of obtaining a 6 is 1 out of 6. So that's 1 over 6. So what you have here is going to be 1 over 12. So these are what? Independent events. So let's take one more example before I finish this class. Like I don't actually want to go into too much thing. You can just make sure you are subscribed to this channel in case I have to. I am because I'm going in the future. I'm going to be uploading a lot of videos that solve problems, answer questions, and then teach you much more in depth of most of the topics that I've taught in these 50 days. I'll be teaching them in a much more in depth manner. So what you want to do is that you want to subscribe to the channel and also like the video as well to always be the first person to get notified when I make such videos. Okay, so let's take it. If you have a box that contains 4 white balls, so a box contains 4 white balls and 6 black balls. So if you have to select, let's say, 2 balls now, and you pick one after the other without replacement, find the probability that both are black. So if both will be black, so you pick the first thing. So you want to pick 2 balls. That means that I pick the first ball and I pick the second ball. You can see now I'm using the word and. So picking the first ball, this place total whatever is going to be 10. So how many? What's the favorable outcome of picking black balls? That's 6 divided by 10. And so I'm going to use multiplication. But I've already picked one ball here. So that means that the number of black balls that will be left will be 5. And also the number of total balls that will be left is going to be what? It's going to be 9. So in that case, I have 2 can divide this. This is this. This is this. So and then 3, and then you have 3. So the probability of that event is going to be 1 over 3. Yeah, and that's basically what probability is all about. Of course, yes, there are some other very, very advanced concepts about probability, But this is just the preliminary phase to introduce you to probability, and it helps you understand any further complex thing that you would come across. So that's it for today. I'll see you in tomorrow for the last class. That is on radioactivity. That will be the last class in this series. Don't forget to like and subscribe to the channel. I'll see you around.